Hey team, I'm Maddie. Welcome to ScienceSideUp, and today we're going to talk about the current extreme winter weather going on here in Oklahoma and south of us down in Texas. Since we've been talking here on the channel about climate change and climate dynamics, I thought this would be a really good opportunity to talk about some of the real world extreme weather and how that relates to climate change. There's two main things I want to talk about today. One, if the planet is warming, how can you get snow in Houston, right? That's a very common thing that people like to point to of if the planet was warming, stuff like this, cold weather events, surely wouldn't happen. So the short answer to that point is that climate talks about trends, right? This is what we've been talking about this whole series with climate dynamics of the difference between climate and weather. And so this is an extreme weather event. The easiest way to think about questions or arguments based in how can the planet be warming when it's cold right now or when there's snow on the ground is it's the difference between an extreme event or an outlier and the average behavior. Think of it like this. The average height of a woman in the United States is about 5'7", right? Which is my height, huzzah. But I personally have known women who are less than 5 feet tall, who are 4 foot something, and I've known women who are 6'3". So just because those two extremes are true and happen and occur doesn't change the behavior of the mean. So think of climate as kind of an average look. It's an overall picture. If the average height of women in the United States was to increase from 5'7" to 5'8", that would say overall height of women is getting higher. But that doesn't mean that 4'9" women ceases to exist, right? So it's the difference between climate and weather is really thinking about the difference between the average and what is true of a single person or a single event. All right, now the second, actually kind of more complicated point about this extreme winter weather is, believe it or not, a warming climate may make events like this more likely. So the title of this video is The Extreme Weather in Texas Caused by Climate Change. And that is a very difficult question to answer, so let's rephrase it thinking like a climate scientist. We would rephrase that as, does a warming planet increase the likelihood of extreme weather events like the one in Texas? In reality, it's almost impossible to draw a direct through line of A caused B of climate change to a single weather event, but we can talk about whether or not types of weather events are going to become more likely or maybe more extreme. So we're going to talk about likelihoods, percentages, things like that. So to answer this question, we need to talk about the jet stream. So I am sorry that I didn't put a video out last week. It has been too cold to be in here to film for 2 weeks. And we did end up losing heat for a couple days. So I just, my husband and I and our dogs had a pillow fort in one room for a few days. And here is Shep, the sweetest giant lapdog ever, not letting us play board games to entertain ourselves. Yeah. Oh, here is the snowdrifts from my backyard. This was a little nuts. I think it looks like a waterbender showed up, but that's just me. Here. Yes, I'm using crayons. I'm building some visual aids to talk to y'all about the jet stream. Yeah. My heart definitely goes out to Texas. It sucked being without heat here for a couple of days, and we still had power, so we could plug in a space heater, and we're pretty warm. We never lost water. We were never under like a boil order for water. We were requested to like conserve water, conserve power, but like that's not that big of a deal. And we were actually never directly affected by the having to conserve power, because that was like, keep your house no warmer than 65. And I was like, cool, it's 47. All right, got an arrow. So I wanted to talk to you guys about the jet stream, and that's what we need to understand what causes, like atmospheric wise, these types of weather events. So I have my slightly deflated globe. Okay, the jet stream is wind, it's just air, right? And it blows like pretty globally. This is not cut to size, it's fine. It is winds that just globally go around the earth, moving from west to east, the direction of this arrow. And they're generally like here in the mid latitudes. So this might move up and down a little bit, but this goes all the way around the globe. Are these just pretty persistent, constant, upper level winds. So we don't feel them down here at the surface, but this is why it takes less time to fly from New York to London than it does to go backwards. When you're going to London, the jet stream is pushing you along. If you were going from Europe to the States, you'd be fighting against the jet stream. I think it adds about an hour to the flight. I'm not super sure on that. But the point is that it takes longer because you're fighting against the jet stream. Okay, so there's our jet stream. And when the jet stream is really strong, or we'll keep the arrow up, really strong, like our big arrow here, it serves as almost a boundary. I just realized that my microphone is clipped to my hoodie, not to my hoodie itself, but to the little thing here. So let's move that. All right. Boop, boop. All right. When the jet stream is really strong, it serves almost as a barrier between this real cold Arctic air and kind of keeps it up over the North Pole, over the Arctic region. But if the jet stream weakens, then it's much easier for air masses up here to make the jet stream like kind of wavy. Waviness, believe it or not, is a real weather term. It annoys a lot of old school weather meteorologist people because it's not well defined. But yeah, the waviness of the jet stream is a real thing I've had conversations about. So this picture with our string here would be not wavy at all, a perfect circle. But what happened this last week was air from the Arctic came down and pushed on that jet stream, not quite that far. So it didn't like break it, it's still there, it just moved it really far south. And that's hard to do with a strong jet stream and a little easier to do with a weaker one. So hopefully what you can see in this very rough picture here is that what happened last week wasn't some crazy thing happened down in Texas that made the air cold, right? It was a bunch of already really cold air from the Arctic moved south. So with global warming, that's not gonna change Arctic air to not be cold anymore. Arctic air is still gonna be colder than Texas air, right? So when we can move this Arctic air south, that's how you get these extreme cold events. And this was already, anyway, so that's kind of what went on. And what we can say about a globally warming planet in terms to strength of the jet is that a warming planet may lead to a less strong jet stream, and or a wavier jet stream. So those are getting into like the nitty gritty of climate dynamics, and I hope this really highlights for you how complicated a system this really is. Because it is complicated, and a lot of really smart people are working on it because they want to understand the system and they want to help y'all stay safe. And they want to help drive policy that will help y'all stay safe. That's the goal. There's not a lot of nefarious purposes in climate science, despite what some people on the internet may think. Yeah, so to answer the question at the top of this video, was this weather in Texas caused by climate change? Maybe. And will a warming planet make events like this more likely? Also maybe. It will likely weaken the jet stream, which would favor events like this. Like I said earlier, it's effectively impossible to draw a straight line of causality. But I do know it's a common thing amongst like climate skeptics, or just everyday people that don't think about this all day, every day, to not understand a lot of the complexity of climate science, and also want to be like, see, every time there's some kind of crazy major weather event, people are gonna tie it to climate change, and all of these things can't possibly be related to climate change, but they kind of are. This event certainly was possibly, right? Yeah. So, I think that's all I have for you guys. I hope that made sense. It's now like in the 50s, so we've got a heat wave over here in Oklahoma. I should be able to get back to a more regular filming schedule and not have to like huddle in my bedroom with the dogs, though they're a little sad that we took down the pillow fort. So I hope you guys are well. Those who care about are well. Please like, subscribe, don't forget to be kind, and I will see you all next time. Bye team, stay warm!